Alright, so this is the first part of a three-part problem, and in this first part I'm basically going to be going over a description of the problem, and I'm going to be doing the dimensional analysis using the Buckingham Pi method. So for this problem we have some air flowing through a tube, and the tube itself is wooded, and outside of the tube we have a liquid flowing, which is H2O. And first I'm going to be going over the different variables of this problem, and then I'm going to place them into a matrix with the base units, and then after that I'm going to explain how we use ranking to identify the dimensionless groups, and then after I identify the dimensionless groups I'm going to determine what their formula is based off of using the system of equations method to solve that. And then once I identify the formula for our dimensionless groups, I'm going to be coding the rest of the problem out in Python. So the different variables that we are going to use is first the mass transfer coefficient, which is Kc. So we have Kc, we have velocity, we also have density, and the mass diffusivity, viscosity, and we also have the diameter of the tube as well. So the units for each of these as follows. So for the mass transfer coefficient and for the velocity, it's meters per second. For density, it's kilograms per meters cubed. For mass diffusivity, it is meters squared per second. For viscosity, it's kilograms per meter second. And diameter is just in terms of meters. So for our matrix, we are going to have, for the rows, we're going to have the different base units for each of these coefficients. So we have kilograms, meters, and seconds. So we have Kc, velocity, density, mass diffusivity, viscosity, and we have the diameter. So for kilograms, the first two are going to have 0 because there's no kilograms there. So 0, 0. Density is 1. Okay. And then we have the mass. So 1, 1, and then for the density it's -3 because it is in terms of kilograms per meters cubed. So the mass has is put to the power of -3 because it's on the denominator. And for the mass diffusivity, it's 2. Viscosity is -1, and the diameter is 1. And for seconds, you have -1, -1, 0, 1. It's also -1, -1, and 0. So for the next part of this problem, I'm going to be talking about the ranking. So to solve for the ranking, I used Python. It was extremely simple. I basically just put this matrix into Python using NumPy, and then I use the ranking function to determine what the ranking is, and ranking is also part of NumPy. So basically what these symbols stand for, so the N is the number of the different variables in the problem, and the R is the ranking, and you can basically just put in the matrix and then it tells you what the ranking is. You subtract that from your total number of variables, and the resulting number is your number of dimensionless groups. So in this problem I have 6 variables and my ranking was 3, so 6 minus 3 gives us 3 dimensionless groups. So starting off with the first one, so I had my first dimensionless group, or I will have my first dimensionless group as using the KC variable. So I'm going to do KC times the mass diffusivity times the diameter times the density. And for the exponents of the mass diffusivity, density, and diameter, I'm going to assign them as A, B, and C. And for the second group, it's going to be very similar, but I'm going to use velocity instead of the mass transfer coefficient, and I'm going to assign another power to, or assign different exponents. So I'm using DEF for the mass transfer coefficient, density, and diameter, and for our third pi group we are going to use viscosity. And I'm going to use G, H, and I. So the next part is to basically solve for the exponents of each of the dimensionless groups. And I also wanted to mention that the first dimensionless group is our Sherwood number. The second group is our Peclet number. And the last group is our Schmidt number. So to solve for the unknown exponents, we're going to make a systems of equations. So for the first pi group, so we're going to go by the different base units. So for mass, for the first pi group, we have 1 plus 2a minus 3b plus c, and for the kilograms we have there is only one term with kilograms in it, and that is the density. So we know that our B equals into 0 because all of these must equal 0. And for the seconds we have -1 minus minus a, and yeah, that's it. So we know that a equals -1 and that b equals 0, so then we can plug that back in and we would get -1 plus c equals 0, and we know that c equals into 1. And because the second dimensionless group has the same has basically the same units, because we're using all the same variables except for we're using velocity instead of the mass transfer coefficient, and we know that the mass transfer coefficient and the velocity both have the same units, so we can set the exponents equal to each other. So we have a equals into d, b equals into e, and c equals into f. And then after that, we can solve. So this is all for the second pi group, and then for the third pi group, so first we have viscosity. It's going to be -1 and plus 2g minus 3h and plus I. And for kilograms, let me double check that. Okay, I think that looks good. And then, so for kilograms, it is -1. Oh wait, sorry. That is just 1, and then plus h equals 0. So we know h equals -1. And for seconds, we have -1 minus g and equals 0. So g also equals into 1. So because for this system of equations we have -1 minus g equals 0, so g has to equal -1. But yeah, so we plug that in, then we get -1 minus 2 plus 3 plus I equals 0. So -1 minus 2 plus 3 plus I equals 0. So we know that I has to also equal 0. And so because we have all of our exponents written out, then we can write out what the exponents are for the dimensionless groups. So for the Sherwood number, which is pi1, we have kc over dab, because dab for a, we found out that that's -1, so we're going to raise dab to the power of -1. And then the density is going to be to the power of 0, so we take that out. And then the diameter is 1. So we have that on the top here. And then for pi 2, we have the same thing, but we're going to have velocity instead of the mass transfer coefficient. And then for pi 3, we got viscosity times we have viscosity over the mass diffusivity and then we also have density on the bottom as well, and yeah, that's it. So to get our Reynolds number, we're going to divide the second dimensionless group by the third dimensionless group. So again, for the first group we have the Sherwood number, and then for the Reynolds number we have the Peclet number divided by the Schmidt number, and for the third dimensionless group that's going to be our Schmidt number. And so for our code to calculate the Sherwood number, that's going to be a times the Reynolds number to the coefficient, or to the exponent of b, times the Schmidt number to the power of c, and those a, b, and c's are going to be used in an unknown matrix later, and we're going to solve the rest of this problem in Python. So let me write out the Sherwood number formula. So once again, this is going to be our a unknown times the Reynolds number to the power of b, times the Schmidt number to the power of c. And once again, to get our Reynolds number, that is going to be pi over 2, or pi 2 divided by pi 3. So our mass diffusivity is going to cancel out, and it's going to leave us with the velocity times the diameter times the density over the viscosity.